You are sitting in a restaurant. The sky has just turned dark. There is nothing to worry about except choosing a dish. There is no survival pressure. There are no enemies lurking outside the door. There are only you, the menu, and the gentlest question, what to eat tonight. And somewhere, on some morning 3 million years ago, one of your ancestors woke up in the African savannah and had to answer that exact same question but with a completely different risk. Not choosing wrong and feeling a little regret, but choosing wrong and dying. This is the story of what humans ate before there was fire. Not steak, not pan-seared salmon, not the air fryer you bought last year and used 3 times. We are talking about the period when eating was not a culinary experience but a survival sport, a test of intelligence, and perhaps the foundation of everything we later called civilization. Because this is something no one tells you. Cooking is the only behavior that appears in absolutely every human culture ever recorded on this planet. Not language, not music, not religion or art or law, only cooking. And if cooking is what defines humanity, then what defined us before it existed? Let us begin with food. Because before you can ask what ancient humans ate, you need to know who they were, and the answer to that question does not look like anything you have ever seen in movies. The clearest evidence of the diet of our most distant ancestors comes from a place called Sterkfontein Cave in South Africa, where scientists at the Max Planck Institute just published a study in the journal Science in 2025 after analyzing the fossilized tooth enamel of 7 Australopithecus individuals. They found no sign of meat, not a trace. The nitrogen isotope ratios in those teeth were low and consistent, equivalent to grazing animals of the same period, significantly lower than any predator around them. At that time, our ancestors were not Homo sapiens. They were Australopithecus creatures weighing about 30 to 50 kilograms, with no fangs, no claws, nothing physically special, and completely not at the top of the food chain. They ate plants, they chewed leaves, they dug for roots. They picked fruit when it was available, and when it was not, they ate something else that also came from the ground. Every day for hundreds of thousands of years, every pre-human ancestor woke up and spent the majority of the day chewing, not cooking, not processing, just raw chewing, continuously, for many hours because living plants have such low calorie density that you had to eat a lot, and for a very long time just to survive. Modern chimpanzees, the species closest to us genetically and closest to our ancestors in diet, spend about 50% of their total waking hours just chewing. That was the default diet of the hominin lineage, not heroic, not epic. And nothing at all like the image of cavemen waving clubs chasing mammoths. Richard Wrangham, a primatologist at Harvard University who spent years studying chimpanzees in Uganda and ate their food himself to understand the experience from the inside, described the result with admirable calm. 10 minutes to finish chewing one piece of raw fruit that was tough, fibrous, and bitter, and the calories extracted after all that effort were barely enough to compensate for the energy spent chewing. He drew a conclusion we will need many times in this story. Modern humans with small jaws, small teeth, and short guts like we have today could not survive on the raw plant diet of primates, not because we do not want to, but because the biology of our bodies is simply no longer built for it. And this is where everything starts to get interesting. If our bodies are no longer suited to a raw diet, then what changed? When did it change? And what happened in the time in between? But before we get to that answer, we need to pause at a more important moment about 3 to 4 million years ago when the planet decided to change the rules midway. The African climate began to shift, not gradually in a way you could adapt to slowly, but in a way that if you did not change something about how you lived, you would disappear. Forests shrank, grasslands expanded. The dense tree canopies that once covered much of Africa gave way to vast open fields of grass stretching to the horizon, dry, hot, and with almost nothing a fruit-eating forest primate would recognize as food. This was the simplest existential question evolution ever posed: adapt or die. And the evidence of what our ancestors chose to eat in that situation is preserved in something no one thinks about when talking about culinary history: fossilized tooth enamel. Scientists measure carbon isotope ratios in tooth enamel to determine what type of plants the creature ate while alive. C3 plants are forest trees, leaves, tropical fruits, the kind hominin ancestors ate before 4 million years ago, similar to modern chimpanzees. C4 plants are grasses, wild grains, and grassland species. And when researchers analyzed fossilized tooth enamel from around 3.5 million years ago, they saw the C4 ratio begin to rise sharply. Our ancestors were eating something from the grasslands. Not grass literally, their teeth were not suited for chewing raw grass, but what lay beneath the grasslands: tubers, roots, underground stems, the starch-storing organs plants use to accumulate energy through the dry season, buried deep underground, out of reach for most animals. A study published in the journal Science in 2025 by Luke Fannin and Professor Nathaniel Dominy at Dartmouth provides astonishing evidence. Our ancestors began eating underground tubers before they had teeth suited to chew them. Read that sentence again. Behavior appeared before the body had evolved to support it. Scientists call this behavioral drive, and this is the first time that concept has been proven with hominin fossils. There was a reason they did it even though their teeth were not yet suited. Underground tubers were a year-round carbohydrate source, not dictated by seasons, did not disappear in the dry season, and more importantly, almost no other species on the grasslands had a way to dig them up. It was a nearly uncontested food source if you were smart enough to find it and patient enough to dig. Of course, anyone who has ever bitten into an unprocessed fresh cassava tuber knows that edible does not mean easy to eat, but they still ate it. Not because instinct told them to, but because they observed, experimented, and decided that this tough and unpleasant thing was still better than nothing. Not instinct, that was a decision, and that was the first boundary between our ancestors and every other species standing on that same grassland. But that decision was only the first step, because the African savanna did not just have tubers, it also had carcasses. And this is where the story goes in a direction most documentaries never dare tell, not because it is wrong, but because it is not heroic enough for a poster. Forget the image of brave prehistoric humans holding spears charging into a herd of wild buffalo. The most likely scenario for the first time our ancestors ate meat looked like this. A lion had just killed its prey, eaten its fill, and left. A small group of hominins stood at a distance watching, waiting, calculating. When the lion left, they ran in as fast as they could because hyenas were already on the way. Not heroic, not epic, but possibly the most important decision any hominin ever made. What made that moment truly meaningful was not the leftover meat on the carcass. The lion and vultures had handled that pretty thoroughly. What mattered was inside the bones. Bone marrow thick, calorie-dense fat, low in pathogens, was a completely empty food niche on the African savanna at that time. Lions did not care about bones after they were full of meat. Hyenas could crush small and medium bones, but not the thigh bones of an adult wild buffalo. No species on that grassland could access what was inside the thickest bones except one smart enough to pick up a stone, shape it appropriately, and use it to smash. This is not speculation. At the Gunna site in Ethiopia, archaeologists found animal bones with cut marks from stone tools along with an Oldowan tool assemblage dating to about 2.6 million years ago. Not evidence of hunting, but evidence of using tools to butcher meat and smash bones for marrow. Smarter than hunting in that it did not require you to face the prey while it was still alive and able to fight back. Raw meat was not easy to eat, tough, hard, requiring far more effort to chew and digest than anything they had eaten before. But they still ate it. Not because they were braver or stronger than other species, but because they observed long enough to recognize there was something valuable that no one else could reach, patient enough to wait for the right moment, and smart enough to turn a stone into the key that unlocked that food source. Not strength, not courage, intelligence, and that was the only thing that truly made the difference. But how do we know all of this? No one left a diary. There are no menus carved in stone. There are no cave paintings showing a hominin eating a tuber in the morning and picking up bones in the afternoon. The answer, and this is one of the truly beautiful things about paleoanthropology, lies in the teeth. Teeth are the hardest tissue in a mammal's body and can survive millions of years in the ground while the rest of the body has long since dissolved into dust. And they preserve information about their owner's life in astonishing ways. Carbon isotopes in tooth enamel tell you what type of plants you ate. Nitrogen isotopes tell you where you stood in the food chain. Microscopic wear traces on the surface reveal what you ate that was hard, what was tough, what was crunchy. And dental calculus, the calcified plaque layer your dentist always reminds you about in a gently scolding voice, preserves inside it starch grains and plant remains from the actual meals of the owner. Not speculation, but real physical evidence. At Fuyan Cave in southern China, researchers analyzed dental calculus in hominin fossils dating from 80,000 to 120,000 years ago, and found starch grains from oak acorns, roots, tubers, and grass seeds. Not someone guessing they might have eaten those things, but actual starch grains sitting in their teeth waiting for us to find them after tens of thousands of years. At Dikaka, Ethiopia, near where Lucy's fossil was found, archaeologists discovered animal bones with stone tool cut marks dating to about 3.4 million years ago, pushing back evidence of hominins processing meat nearly a million years earlier than previously known. This evidence remains controversial, but it raises the real question: if even Lucy may have had access to animal meat, then the line between eating plants and eating meat in human evolution was not as clear as we thought. And then there is something else. The fossils say something that leads straight to the biggest question of this entire story. At Wonderwork Cave in South Africa, burned bones and plant ash were found deep inside the cave, far from the entrance, so they could not be the result of natural wildfires dating to about 1 million years ago. And a 2022 study at the Gisher Beno Yaakov site in Israel found deliberately heated freshwater fish teeth dating to about 780,000 years, the earliest known evidence of cooking a specific food. That means fire in the sense of actual cooking only appeared relatively recently in the millions of years of human history. So throughout all those years before that, before any fire evidence we have ever found, what did they eat and how did that shape them? That question leads us to a problem many people do not realize until they think about it carefully. In recent decades, there has been a movement called the Paleo diet, the idea that there was a fixed, primitive diet that the human body was designed for, and all the problems with modern health stem from us straying from that menu. The idea sounds reasonable. It is also completely wrong. There was never one fixed primitive diet. Never. Looking at modern hunter-gatherer communities is enough to understand why. The Hadza in Tanzania get about 70% of their calories from plants' tubers, wild fruits, honey, and meat is only secondary. The Inuit in the Arctic are almost the complete opposite, nearly 100% of calories from meat and marine animal fat because the environment simply has no vegetables. The Kung in the Kalahari change completely with the seasons. The same person eats very differently in the rainy season and the dry season. There is no formula. There are no unchanging rules. The only common point is not what they ate, but the ability to adapt to whatever was available in the surrounding environment. Not fangs or claws, but dietary flexibility is what allowed humans to settle in every environment on this planet. This also explains why evidence of fire and cooking is so scarce in the archaeological record. The Hadza cook on small temporary fires outdoors, the kind of fire that leaves nothing behind after rain, let alone after 1 million years in the ground. Fire evidence is only preserved when burned in enclosed caves and ash accumulates through many stable sediment layers. Absence of evidence does not mean absence of behavior. This is the most important logic trap in the field, and it needs to be called out directly. Food is not just nutrition. It is the first reason humans needed to talk to each other. And to understand why that matters so much, we need to talk about a man sitting in an office in Cambridge in 1997, looking at a pile of fire and asking a question that changed the way humanity understands itself. That man was Richard Wrangham, but not the Wrangham we met earlier, gnawing on raw fruit in Uganda. This time it was Wrangham, sitting in an office in Cambridge in 1997, looking at a pile of fire and asking a question that later took him more than a decade to fully answer in his book, Catching Fire, published in 2009. That question was, if cooking appeared early enough in human history, could it have been the cause of human evolution, rather than the consequence? Wrangham's central argument completely reverses the way most people think about the relationship between intelligence and food. Not a big brain leading to cooking, but cooking leading to a big brain. The arrow of causality runs in the opposite direction, and the evidence lies in an evolutionary paradox that no one had explained satisfactorily before him. About 1.8 million years ago, Homo erectus appeared in the fossil record with a significantly larger brain than its ancestors, but at the same time smaller jaws, smaller teeth, and shorter guts. By ordinary evolutionary logic, this was completely absurd. Why would a species evolve in the direction of reduced capacity to digest raw food when raw food was the only thing available? Wrangham's answer: because raw food was no longer the only thing available. They had fire. And fire changed everything chemically in ways we are still fully understanding even now. When you heat starch, what happens at the molecular level is a process called gelatinization. When the tight crystalline structure of raw starch is broken down, the starch molecules swell and open up, and the digestive enzymes in the gut can suddenly access them easily. The same tuber cooked provides significantly more calories than eaten raw, not because anything is added, but because the body can suddenly extract what was already there. With protein, the same thing happens through a process called denaturation, when heat unfolds the complex folded protein chains into simpler, straighter forms that the stomach can break down far more efficiently. Collagen and elastin, the things that make raw meat so tough you have to chew it for dozens of minutes, are broken down by heat, and many plant toxins that make some food sources dangerous or inedible when raw are completely neutralized by high temperatures. In short, cooking is digestion outside the body, and fire is a second stomach. The consequence of that for the evolution of the human brain was calculated with cold precision by the Brazilian neuroscientist Susana Herculano Rosell in a way that makes listeners pause. A gorilla that wanted a brain the size of a human's would need to eat about 2 extra hours every day compared to its current level, pushing total chewing time up to 10 to 11 hours per day. 11 hours per day just to chew, no time left for almost anything else. The math simply does not allow a large brain to exist on a raw diet. Because the brain is unimaginably expensive in energy terms, it consumes about 20% of the body's total energy while making up only about 2% of body weight. And in every other primate species on this planet, the gut is heavier than the brain. In humans, that is completely reversed. Our brains are heavier than our guts, a reversal that could only happen if the gut no longer had to do heavy work on raw food, because the food had already been processed before it entered the mouth by fire. We traded guts for brains. And the meals before fire, all those years of eating raw tubers, scavenging bone marrow, experimenting with anything that could be eaten, were what set the stage for that trade. But the story does not stop at biology. Because the most interesting thing about food in human history is not what it does to the body, but what it does to the relationships between people. Sarah Hrdy, an anthropologist at the University of California, Davis, in her book Mothers and Others, points out a behavior that humans do completely normally, but is actually extremely unusual in nature: sharing food with individuals who are not your own offspring. Most primate species do not do this. Chimpanzees sometimes share meat after a group hunt, but not out of altruism, but to establish power relations, to attract mates, to buy the silence of rivals. That is a transaction, not sharing. Humans are different. We share systematically with the elderly who can no longer forage for themselves, with children who are not yet capable of foraging, with the sick, who contribute nothing to the common food supply. Those individuals, according to the coldest evolutionary logic, are burdens, but we feed them anyway. And to do that systematically, you need something chimpanzees do not have enough of: trust. Trust that others will do the same for you when your time comes. Trust is the foundation of society. And society is the first cultural form humans ever built, before complex language, before art, before anything we usually call civilization. Wrangham did not stop at biology. He also argued that the campfire was the origin of the household, the most basic social unit of our species. Not the state, not the clan, not the tribe, but the hearth. The reason is so simple, it sounds trivial. Fire needs to be tended. Cooked food needs to be protected from other individuals in the group who want to take it without contributing. One person alone cannot forage for food, tend the fire, and protect the already cooked food at the same time. Someone with a reliable partner, who stayed to tend the fire while the other went out to forage, then shared the results equally upon return, had a clear survival advantage over the lone actor. The earliest division of labor in human history may not have come from culture or tradition or any conscious decision by anyone, but from the simplest survival logic around a campfire. And then something else happened when humans began sitting around the fire in the evenings, with full bellies, predators kept away by the light, no need to spend every waking hour chewing or searching for the next meal. They had time. For the first time in the evolutionary history of a primate species, there were hours in the day not needed for direct survival. And in those hours, language flourished, storytelling began, knowledge was passed from one person to another, plans were made for the next day. Fire did not just cook food, it created time for humans to become more human. And all of that began from the simplest question: what are we eating tonight? And while language flourished and society formed around the hearth, the human body was also quietly changing at the genetic level, generation by generation, so slowly no one noticed until we had tools to read the genetic map. Let us begin with the gene AMA1, the gene that codes for the enzyme amylase in saliva, the enzyme that begins breaking down starch as soon as food touches your mouth before it even reaches the stomach. Humans have more copies of AMA1 than chimpanzees and most other primates, sometimes significantly more. The mechanism is very simple. Ancestors began eating tubers and plant starches before their bodies were optimized to digest them. Over many generations, those individuals with more AMA1 copies extracted more calories from the same amount of food, stayed healthier, and reproduced more. That gene spread through the population not because anyone decided it was useful, but because those who carried it simply survived better. Behavior came first, biology followed thousands of years later. A similar story happened with the lactase gene, but more recently and easier to observe. Most mammals stop producing the enzyme to digest lactose after weaning, that is the normal biological state. But when some communities began herding livestock and drinking milk regularly within a few thousand years, the gene allowing lactose digestion in adults appeared and spread in Northern Europe and some African pastoralist groups. Culture came first, biology followed. And that is happening right now, only too slowly to see in a single lifetime. If you still need more direct proof that the human body is no longer suited to a raw diet, look at modern communities that choose to eat completely raw. They cannot maintain stable weight over time, and about 50% of the women in those communities develop amenorrhea because the body shuts down reproductive capacity before shutting down any other function when calories are insufficient. This is not a criticism of a lifestyle, it is evidence that our bodies have changed to the point where there is no going back, and what changed them was millions of years of accumulated decisions about food generation after generation until our biology became the record of that entire culinary history. But before we end this story, we need to talk about what happened to food in the last 150 years, because it is the strangest and most disturbing part of this entire 3 million-year journey. Humans went from find something in the grassland and hope it is not poisonous to creating thousands of products calculated precisely to activate the pleasure centers in the brain as optimally as possible in a time frame so short evolution had no way to keep up. Your brain was built in an environment where sugar and fat were extremely rare. Every time you found something sweet or fatty, it was a real survival victory that needed to be remembered and repeated as soon as the opportunity arose. The reward system in the brain evolved to do exactly that, marking those valuable calorie sources with powerful, pleasant sensations so you would come back. And the food industry knows that, has studied it for decades, and has built its entire business model around exploiting it systematically. Ashley Gearhart at Yale University has spent years researching what she calls food addiction, arguing that some ultra-processed products activate neural pathways similar to addictive substances, not in a metaphorical sense but in the literal sense of neuroscience. Not because consumers have weak willpower or lack discipline, but because the products are designed, tested, and refined through thousands of iterations to do exactly that: activate strongly enough that you want more, but not strongly enough that you are truly satisfied, because true satisfaction means you stop, and stopping means revenue drops. Our ancestors spent their entire lives trying to find enough to eat to survive the day, each meal, the result of observation, effort, and sometimes luck. The modern food industry spends billions of dollars every year to ensure you are never truly satisfied, because the entire profit model depends on that dissatisfaction being maintained indefinitely. Ancestors ate to live. We have been engineered to live to eat, and that is not evolution, that is deliberate design. A forager sharing a tuber with the whole group at the end of the day, and a corporate executive approving the addition of 15% fructose to a product labeled healthy, are both doing something related to food. But the moral distance between those two actions is wider than 3 million years of human history combined. So that is the story, not the heroic story we often tell about our ancestors: no brave hunters, no conquest of nature through muscle and willpower. But the story of small, vulnerable creatures near the bottom of the food chain, facing a changing planet and figuring out how to survive, not through strength, but through observation, experimentation, and sharing what they learned with each other. From leaves and roots to underground tubers to bone marrow to raw meat to cooked food, each step in that journey was not pure biological evolution happening to them like weather happens to a rock. Each step was a decision, an experiment, an observation shared and passed on. Culture was being created in real time, one meal at a time, before anyone had words to call it culture. And this is the philosophical question I want to leave with you. When we ask where culture began, the question that philosophers, anthropologists, and historians have debated for centuries, most people answer with art or language or religion or law. But all of those came later. What came first? What required trust and cooperation and transmission of knowledge and care for those who could not care for themselves? What built everything else from its foundation was the shared meal with others. The meal before fire asked the question. The meal after fire answered it. And both are you, written into your genes, into the shape of your jaw, into the length of your gut, into the way your brain responds to the smell of food cooking. The next time you sit down at a table, whether it is a family meal or a bowl of instant noodles at midnight, or the restaurant with the menu where we began this story, you are asking the oldest question our species has ever had. And your ancestors, those small creatures on the African savanna 3 million years ago, found an answer good enough for you to be sitting here asking it again. If you found this 3 million year story worth listening to all the way to the end, then perhaps the next stories will be to subscribe to the channel so you do not miss the next time we dig deep into a question that seems simple but turns out to be anything but. And if you have a friend who likes to argue about the paleo diet, share this video with them. This is the most polite way to say they are wrong.